Hey guys, it's Miss Johnson here, and I'm here to bring you our notes for Unit 2, Notes 2 on graphing systems of inequalities. Today our learning target is I can graph systems of inequalities. Now, first we should probably talk about what a system of inequalities is. We spent a lot of time yesterday on graphing systems of equations, putting more than one equation on a line on the same coordinate plane and looking for where those equations intersect. Now, our inequalities, systems of inequalities, are very similar. We're taking more than one, or two or more, I should say, inequalities on the same graph. Okay, so a system of linear inequalities is a set of two or more inequalities on the same graph. The solution to that system is the region where both of the inequalities are shaded. So we all know how to shade inequalities now, graph them using the solid or dotted line and all that stuff. So when we look at two or more on the same coordinate plane, what we want to look for is this overlapping piece here, where the two inequalities overlap each other. Okay, that's our solution set. So if you were to look at a graph of those, the solution set would be where the two shading regions overlap. Solving a system of linear inequalities is sometimes called linear programming. We'll call that linear programming. You'll do a little bit with linear programming when you get to Algebra 2. So let's just do some examples together. In number 1, you have the inequalities y is less than negative x plus 1 and y is less than or equal to 2x plus 3. So they're both in slope-intercept form already. I want to just take them both and put them on the coordinate plane. For the top one, I'm going to go up to positive 1, and then my slope is negative 1, so I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. Now it's really important, just as it was when we were only graphing one inequality, that our line, ooh, and I almost forgot here, it actually should be a dotted line. There we go. Our line needs to go across the whole coordinate plane, not just part of it. Okay, so this is where our line would, what our line would look like, and then I want to shade below that line, so that's shading out this way. Now, I recommend that you shade kind of lightly on these because you're looking for the overlap when you've got more than one on the same coordinate plane. So notice that my shading isn't like solid, it isn't all the way colored in. You're going to want to be kind of particular about shading lightly for the two to see where the two overlap. Otherwise, you're not going to be able to see it very easily. For our purposes, I'm going to use two different colors, and you can do this too. If you're working in pen or highlighter, sometimes you can highlight in two different colors. So now I'm putting my next line on the coordinate plane. I went up to positive 3, and then my slope was 2, so that's up 2 over 1, up to right 1, down to left 1, down to left 1, down to left 1. And this one is a solid line. So I am going to do a solid line there like that, all the way down. And again, I'm shading less than, so the less than for this line would be this direction. And here's where you can go back and darken in that piece that's overlapped. Now we're not so concerned about the one point. There is a point of intersection here of the two lines, but that's not really what we're looking at. More so, we're looking at the overlapping of the shading. So it's this region all right here. That's where my overlapping is. All right, so let's try number 2 together and just see how we do here. In number 2, you have y is greater than x plus 1, so that is up 1, and then the slope is positive 1, so up 1 over 1, up 1 over 1, up 1 over 1. This is a dotted line. And then the bottom line, x is x minus 3. Oh, I tried to shade. Hello. Shade above here. Here we go. So I shaded above that line. Then the bottom one is where I have y is less than x minus 3. So I go down to negative 3, and my slope is still positive 1. So up 1 over 1, up 1 over 1, and so on. And this is a dotted line again, like this. And this time I'm going less than. Now, we're looking for the overlapping shading. And in this case, we have parallel lines. Now think back to yesterday when we talked about systems. Systems that had the same slope, or equations that have the same slope, in this case our slopes are both 1, those lines are parallel. And when you have system with parallel lines, you're not going to have any solutions. Now inequalities are similar, because since these two inequalities are both shaded out. If they were both shaded in the middle here, then yeah, we'd have that little solution set right there. But they're not. This one's shaded up away from the green line, and this one's shaded down away from the blue line. So this is one where we actually have no solution set. There's never going to be a point where those two overlapped region, or two regions that are shaded, overlap. Okay, now that's not always the case with parallel lines, because like I said, we could have shading in the middle here, but the way these lines worked out, they went to the outside. Let's try number 3. Now in number 3, our lines aren't in slope-intercept form, so I gotta fix that first. So I'm gonna start with the top one. The 3x minus y is greater than or equal to 6. I'm just rewriting it here. I need to subtract the 3x term. So that goes away. I'm left with negative y is greater than or equal to negative 3x plus 6. And then I have to divide by negative 1. And when I divide by negative 1, that makes my sign flip over to less than or equal to. I've got y is less than or equal to now positive 3, because negative divided by negative is positive 3x, and then minus 6. Okay, so positive 3x minus 6. So that means I'm starting down here at negative 6. I go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. This is going to be a solid line. And I want to shade below, so that's down here. Again, you don't really want to darken it in yet. We need to see where the overlap is, if there is any. So then let's do the other one. 2x plus y is less than or equal to 4. I'm going to come down here. 2x plus y is less than or equal to 4. I need to subtract the 2x term. So I have y is less than or equal to negative 2x plus 4. That is the line I'm going to work with. I have nothing to divide by, so I'm set. I go up to positive 4, and then I go down to right 1, down to right 1, down to right 1. Again, I have a solid line here. But now I want to shade below again. So I'm underneath that line like that. And then if I look for that overlapped region, the overlapped region is right in here. You were below the red line and below the purple line. Okay. Let's do one more practice question together. Taking a look at number 4, I have x is less than or equal to 3, and x plus y is greater than 2. Now this x is less than or equal to 3, this is going to be a vertical line because there's no y value. We talked about that back in Unit 1 when we were graphing equations there. No y variable. Okay, so where I am, I should say, is I'm over at positive 3 on the x-axis. Okay, and now I want to be less than or equal to 3. It's hard because you can't say shade up or down when you have a vertical line. I know my line's going to be solid, and it's going to be vertical through 3. But there's no up or down in a vertical line. There's either a left or a right. But if I want my x values to be less than 3, the x values that are less than 3 go to the left. This would be 2, 1, 0, negative 1, and so on. So that means that's where I'm shading. I'm shading out here to the left. Okay. So then let's do the other one. In the other one, I need to subtract the x term, get y by itself. So I have y is greater than negative x plus 2. I go up to positive 2, and negative 1x means I'm down 1, right 1, down 1, right 1, down 1, right 1. This is a dotted line, like that. And I want to shade above this time. I'm going solutions that are greater than. So I go above. The overlapping region is right in here, where the blue and the green are both in the same spot. Is right in here. So there is my solution set. Great. I'm going to go ahead and stop our video at this point. Thanks for watching today. Please take a moment to hop back to Schoology and take that Schoology quiz, and we will come back together and finish our notes tomorrow. Have a great night.